The broadcast is now starting. All attendees are in listen-only mode.
It looks like we have 2 minutes, and we'll be starting just in a couple minutes here.
Okay.
Very good.
We're going to go ahead and kick off our ongoing APA webinar series. This is Chris Kopak, Assistant Vice President, University of Arizona, and also current APA President. These APA webinar series have really been very successful, giving back to our members, and that was one of the key items our members had asked. It was useful information they could take back to their universities and colleges and K through 12 to run their operations even more efficient. Today we are going to be talking about nanogrids to campus microgrids, how Santa Fe Community College is working with local community and utility to deploy a microgrid. We have the pleasure of having Clark Wieditz, the Director of Microgrids, 18 years at Siemens Corporation, and also Henry Nardo, Executive Director, Plant Operations Management. He's currently been there 5 years. Has a long history in the industry at our Santa Fe Community College. So gentlemen, we appreciate you taking the time. This is going to be a great topic. We have over 300 to 400 members who are currently on the line. And just a little housekeeping, if any of the folks who are attending the calls have any questions at all, please go ahead and type those to us. And what we'll do is answer those. It's about a 45 minute presentation, and we have 15 minutes for questions and answers at the end. Without further ado, Clark and Henry, we look forward to hearing about microgrids and how we can be more efficient on our campus, seeing that our utilities is a huge dollar amount in our budgets.
Thank you, Chris. Appreciate it.
Thank you, Chris.
Okay, Billy, go ahead to the next slide. Thanks. So microgrids. As a lot of you out there probably know, there are a lot of different definitions of a microgrid out there. You can see one that says it's an integrated energy system consisting of interconnected loads and distributed energy resources, which as an integrated system can operate in parallel with the grid or in an intentional island mode. Another is it's a regionally limited energy system of distributed energy resources, consumers, and optionally storage. Optimizes one or many of the following, such as power quality and reliability, sustainability, and economic benefits. It may work in off-grid, dual, and on-grid mode. Both of those are excellent definitions. I try to keep things really simple, and I say, well, let's take a look at the distributed generation assets that you have. What are the assets that you're thinking about possibly having on your campus? And do those assets run 24/7? If not, then there's a conversation to be had about an advanced control system. Now, whether or not that's a microgrid can be a topic of debate, but it's definitely time for a conversation about an advanced control system, because it may be applicable to you and it may bring some opportunities and advantages for your organization. So with this webinar, we have distributed generation trends that we're going to see in the higher ed marketplace. We're also going to explore the value proposition for microgrids as they apply to a university or a college. What are we doing at Santa Fe Community College? What's the vision of Santa Fe Community College? The benefits of a phased-in approach to distributed generation in microgrids. And lastly, the business structure. The business structure is a hot topic in the microgrid industry. Most of the conferences, that's what we end up talking quite a bit about. There are a number of business structures, but here is one where performance contracting is actually being used. Go ahead to the next slide. So what do we see across the country? None of this should really surprise you. Aging infrastructure with reduced funds to pay for it. Siemens and other organizations are using their own capital and third-party financing. More recent is the need for increased reliability due to storms and other occurrences that we're seeing out there. So this is where distributed generation assets can help, and this is where colleges and universities are adding other DG assets such as CHP, renewable energy, and especially solar. We've seen a significant increase of solar on many campuses over the last 10 years as the price of solar has dropped continuously during that time. Battery storage will also continue in the same path we see as solar PV. We're seeing the cost of that decrease as well. And so what does that lead us to? That leads us to an opportunity to utilize advanced controls and to have a microgrid. Now, there are different business structures that are being investigated via public partnerships, long-term service agreements. For example, have you heard yet of energy as a service or microgrid as a service as potential contract structures? These are things that are now out there that use third-party financing and long-term capital as a way of allowing the public entity to have a better cash flow with these assets that are being installed on the campus. Larger projects are being funded not only through performance contracting, but also what we call DBOOM, design, build, own, operate, and maintain contracts in order to satisfy the risk components for that third-party investor, whoever that may be. And so there are a number of different ones out there. Ohio State is one that was very large, that was recently signed, and that's also, I consider, a success as well. Go ahead to the next slide. So we mentioned distributed generation assets, especially renewable energy, being new assets on the campus. What that also means is the advent of advanced controls or a microgrid controller. Again, don't get caught up in the name microgrid as much as a way of looking at these assets and figuring out a way to improve reliability, reduce cost, sustainability, reduce your carbon footprint, being environmentally sustainable. Go ahead and click it again, Billy. This really shows the bottom line. They provide capabilities and functionalities such as load shedding or load shifting, and that can be a very simple microgrid such as solar plus storage. Or you could have a more complicated application with optimization, market potential, market differentiation assets as shown here, many different assets as shown here on the diagram. So in addition to reliability and improving the campus environment and reducing the carbon footprint, you also, of course, are cutting cost, and that is the bottom line. Go ahead to the next slide. So at Siemens, we look at this as our microgrid solution. And what that means to a client is we say to you, make sure that these 6 elements are covered. Who they're covered by is up to the team as the team forms in this programmatic fashion. Sometimes it could be one entity that takes care of all these or integrates entities to take care of all these. That's fine if that's the way your approach, if that's the approach that you want to take. But A number of others look at it as 6 separate elements, and what we're saying very loudly is to make sure each of these elements are defined and there is someone there to take care of them. Start with the consulting. This gets left out a lot, and what I mean by that is take your time and figure out what is the best approach for you. Again, based on assets that you have, assets that you're looking at, and what are the capabilities and functionalities that you wish to achieve by having these distributed generation assets. It's very easy when you say, okay, we want to have some distributed generation, or we want to have a microgrid with the DG assets that we already have by maybe adding storage. Everybody zooms right to the equipment because that's kind of the easiest one to see first. It is important. And of course, being an equipment supplier like we are, we like that. But we can't leave out the important part of number 1, figuring out the consulting piece as well. And then also number 3, which is the software controls, which is my business. And then after that, you need to make sure that you have the analytics to prove what you have and what you're doing is actually accomplishing your goals and objectives. And then service and maintenance, so that you look at the true life cycle cost of having different generation assets, as well as the controls. For example, you may be able to use advanced controls to dispatch certain assets and thus reduce the total amount of assets that you actually are adding to your campus environment. That type of solution is being done. And then the financing. I mentioned it a little bit earlier with regards to third-party financing and DBOOM, but once again, whether you're using a grant or some other incentive to help, you have to make sure that the financing is available both for the capital project as well as the life cycle for the service and maintenance. By having all 6 of these elements, you will have a successful microgrid project. Now, there's one other thing I want to add as part of this slide is the utility itself. The utility isn't the customer here. The higher ed entity is. But getting the utility involved early is paramount in a successful project. Some might be cringing and saying, really, I don't believe you. I get that. But here's the reason why. They're a key stakeholder. They're going to be a key stakeholder, and they need to have clear understanding of what generation assets are touching their grid. They need to have clear understanding of that substation or that feeder. And if there are issues, we want to get them on the table early so that it can be addressed by either the utility or the end use client or by the integrator or developer or whoever that may be. The successful projects that we've had all included the utility very early on, and that made it work for all parties. Go ahead to the next slide. So our approach to colleges and universities now includes an education and research component. We find that works extremely well for those entities, especially that have engineering and science as part of their curriculum. We work with the colleges and universities that have that, and then of course have a penchant towards distributed generation and obviously microgrid labs. That obviously becomes a no-brainer, right? So we provide the same advanced controls used for a campus microgrid in the lab environment. What that does, the students can run simulations, they can look at a variety of functionalities and applications and capabilities in a kilowatt size environment. And that potentially mirrors what's going on in the campus environment. So it allows them to open up to new ideas. And where do we get new ideas? We're going to get it from students who look at this thing from a completely different perspective than we as an equipment manufacturer, than possibly others, even in academia. That's what we need to get to the next level and make jumps, is to have different people looking at this from different perspectives and to be able to run different types of testing in order to see if their ideas have any merit or have legs, so to speak. That's one of the key drivers there for why we work either cohesively or even first with a microgrid lab, or a nanogrid, as will be described by Santa Fe Community College in a second. Go ahead to the next slide. So reiterating the value proposition for higher ed, it can include potentially monetizing and upgrading aging infrastructure. It's the ability for a client to have no or limited upfront capital. That's also a possibility. You could have Siemens or a third-party investor actually own the asset and even provide an outsource for operations and maintenance if that works best for you. Increased reliability. All of these things are part of your distributed generation or microgrid project. Again, it doesn't have to be one entity to provide it all, but each piece of it needs to come from somewhere, and there needs to be the entities talking and communicating in order to make sure that that integration happens properly. All the while, you can look at a global entity like Siemens that can oversee this, has the experience, and that you can trust in order to make sure that all these boxes are filled by somebody. Go to the next slide. So this is our message to Santa Fe Community College when we started. Be prepared for anything. We want to make sure that they are prepared for anything in a programmatic approach. And with that, I'll turn it over to Henry to talk about Santa Fe Community College.
Well, thank you, Clark. That was an excellent background on microgrid technologies and microgrid engineering, and obviously the microgrid systems. So thank you so much for helping us bring that into perspective. Next slide, please. I'd like to welcome you all and thank you for allowing us to present to you some of our goals and expectations associated with Santa Fe Community College and improvement to our energy efficiency goals as well. You know, I want to thank Siemens for working with us on this project in order to really achieve such a project of large scale, because this really entails an analysis and audit of your entire energy envelope. So you'll need to understand and appreciate all of your energy assets in order to really handle this microgrid transition. And you'll need to have your leadership aboard. So the first thing I, as the Executive Director of Operations here at the college, recommend is to make sure that you have all your leadership understanding the aspects of energy and energy management, and also willing to transition to a greater efficiency and to cut costs. And I don't think you're going to have any problem with anybody accepting the cutting costs aspect of the goals. A supportive community. We've been very communicative with our community, particularly our students, and we've asked for their input and worked with them to come up with some of these cost-saving measures and to come up with some of these energy efficiency goals and our ideas to reduce our carbon footprint. So our community has been very supportive on leading us and helping us move forward with some of these microgrid technology goals. Tradition of environmental protection. We as a community college, we operate our own energy assets. We have a photovoltaic plant. We also operate our own wastewater treatment plant. We have greenhouses on campus, so we grow a lot of our own produce. So we are extremely environmentally conscious, and that is one of our highest priorities, is environmental protection. So anything we do, we obviously consider environmental protection as one of our highest priorities. Next slide, please. Just a kind of a background on the community college. It was established in 1983. On any given semester, we have about 6,500 students, or close to 13,000 students annually. We have about 400 faculty and staff, just to give you an idea of our number of our employees. We have a campus that's 366 acres. We have literally 3 campuses, if you will. We have a main campus. We have a higher education center that's about 5 miles from our main campus. And we, since we don't have an auto facility on campus, we're actually leasing a facility, and we provide auto technologies training at a leased facility. The college itself has about 700,000 square foot. That higher education center I referred to is about 34,000 square foot. That photovoltaic plant that you see in the background left there, that's a 1.5 megawatt photovoltaic array system. It's on about 5 acres. We installed that in 2014 and it's been operational ever since. The screenshot to your right, those are heliodynamic concentrating solar collectors, they're called. And essentially those are thermal collectors on the roof that we use to heat our hot water. For that particular building, it's called the Trades and Advanced Technology Center. We heat that hot water and we use that hot water to both heat and cool the building. It's a solar heated and cooled building. We have a 12,000 gallon thermal tank that we use to store that hot water. Next slide, please. And as I cover some of these energy assets with you, that's one of the most critical aspects of understanding your energy envelope is first to identify those assets and get a broader appreciation of what type of energy you're using and how you could conserve that energy. We've worked extensively with Siemens to come up with a plan. They've been working with us on an investment grade audit so we can audit all of our assets, not only energy, but water conservation, our wastewater treatment plant, and all of our utility assets. So we're auditing those assets so we can not only become familiar with our energy consumption, but we want to come up with some ideas for energy conservation, and we also want to lead ourselves to bringing these assets onto a microgrid management system in the long run. The Trades and Technology Center for Sustainable Education and Embedded Living Lab. This is a building we built in 2012, 2013. It's a LEED Platinum facility. This particular building is about 45,000 square foot. It's solar heated and cooled. We have a PV rooftop array and those vacuum tubes that I discussed earlier, thermal tubes earlier. It's all LED lighted inside the facility. That picture on your right is basically gives you an example of the interior, which shows all of our exposed utilities and HVAC systems. So when we're training HVAC, refrigeration, and green building in this particular lab, we can actually walk outside the classroom and look up to the ceiling of our facility, and we can actually train inside the facility using the existing plumbing and HVAC systems. It's extremely convenient with these exposed piping to train these type of technology to students because everything is exposed, and it provides a great training tool for all of our HVAC and all of our microgrid technology training that's coming up. Next slide, please. So our energy infrastructure landscape, again, and working with Clark and Siemens, which have given us some great technology in terms of engineering and science to be able to understand our equipment, the mode of operation of our equipment, but also the landscape of our infrastructure. So it's important that you really gain an appreciation for all of your energy and utility assets because you will need that knowledge and analysis later on when you start to look at transitioning to a microgrid system. So some of our objectives were to build a prominent industry partnership, and not only with Siemens, but with other industry partners, battery storage, photovoltaic vendors, resources, all the associated utilities, equipment, and management that you have within your physical plant. Those type vendors, it's extremely interesting and extremely valuable to gain a partnership with them because they're going to help you bring those pieces of energy assets and equipment online to your microgrid management system down the road. Identify your goals. We expressed our goals early on. It's extremely important for us to reduce our carbon footprint. We've been looking at our energy conservation since for at least the last 6 years. So we've been looking at and implementing a number of goals to reduce that footprint. We wanted to increase our reliability on campus of our power energy systems. Obviously increase our resiliency. We want to avoid all power outages at any cost because a power outage for our students means we can't conduct classes. And that's not a good situation for our paying students. So We want to minimize any power outages that could occur. And ultimately, we want to have full control of our power management and full control of optimizing our costs, reducing those costs. Understanding your peak demands, you've got to be able to understand your loads and demands, energy loads and demands, to be able to reduce that peak demand. Once you reduce that peak demand, you can lower your overall energy cost for the entire entity or your entire facilities. We're going to start with a nanogrid and end up with a campus-wide microgrid. We refer to it as a nanogrid because we're going to start with a smaller facility, in this case our greenhouse, which we just completed construction. And we're going to add about a half dozen energy assets to that greenhouse and bring them on independently into our microgrid management system and start managing and optimizing those assets once we become familiar with that management system. And we're working with Siemens right now to procure some of our energy assets, natural gas generators, battery storage systems, and switchgear. And then we'll be working with Siemens to bring a microgrid management system on campus to our nanogrid, and then we'll start commissioning and optimizing those energy assets to ultimately use that microgrid management system to control those assets, to optimize the energy envelope of that greenhouse on one hand, and then on the other hand, we'll take that complete system using some simulation techniques and tools, and we're going to provide microgrid technologies training for students so they can actually learn to develop and install some of this microgrid systems and some of these microgrid technologies down the road, because we truly believe in order for those to optimize and manage their energy assets, they're going to be able to have to be able to appreciate a building energy management system, and putting it under a microgrid is just another formality of that management system. Challenges, energy efficiency measures, that's always a challenge. Not only are you trying to manage your conservation, but you really need to take a good look at efficiencies and see how you can improve on those, whether it's running the time cycles of your air handling units, or when you turn your chillers on, when you turn them off. All those aspects of managing your plant need to be looked at for energy efficiency. As I mentioned earlier, we're going to integrate that greenhouse that I referred to as just completed construction with biofuels resources. We have some biofuel generators. We're going to integrate it with our wastewater treatment plant. We also treat our own waste here on campus with the wastewater. We operate our own wastewater treatment plant, and we're combining all that into an energy strategy. So when we get finished with our microgrid analysis, we're going to bring all of our assets, all of our energy and water assets online so we can manage those and conserve with the outcome of being reducing our carbon footprint and reducing our total costs of operation. Because if we can reduce our total cost of operation, then that ultimately reduces the cost of tuition for our students, and hopefully that will increase our student enrollment. That's the ultimate goal. Next slide, please. This is kind of a busy slide, but it goes back to what I was describing earlier. It's extremely critical to analyze and audit all of your energy assets. These are just a few of our assets here on the Santa Fe Community Campus. As you can see, we have identified our rooftop solar thermal systems. We have a 1 megawatt fixed photovoltaic array system. We have that greenhouse hydro and aquaponics system that I was referring to. Our wastewater treatment plant is directly on the bottom of your chart here. So this is just an identification of a campus map and all of our energy assets. So when we're working with our vendors and trying to analyze our energy assets, this is a good starting point to communicate with your vendors and to understand and appreciate your assets. Next slide, please. What we did here was we worked with NREL, the National Renewable Energy Lab. And conceptually, when we first started looking at our nanogrid, this is where we looked at our greenhouse in our classroom. We looked at all the attributes and load requirements with that greenhouse and classroom. Then we coupled that with our tracking array, which we have a 12 kilovolt tracking array that's going to supply energy source for this greenhouse and classroom on your left. And then there to your right, next to the classroom, we have identified other energy assets. We have batteries and chargers. We have some gen sets that are alternative fuel. We have a biodiesel a diesel, and we're also looking at a natural gas generator. And we coupled these assets along with the tracking array, and this was the schematic we used as a conceptual design to come up with our Nanogrid system control for our energy assets that are going to be controlling, that'll be heating and cooling our greenhouse and classroom. So this was a conceptual drawing. It allowed us to provide all of our energy assets, look at all of our heat and energy loads, couple those in a one-line drawing where we can now start to design systems to manage these energy assets, and we can work with Siemens to design our microgrid management system to come up with parameters to optimize these energy management attributes within this greenhouse and classroom. Next slide, please. So again, looking at a picture of our TATC facility, that's to your left is just a visualization of our plumbing lab, and there on the right is is a visualization of our rooftop training portion of the facility, which allows us to actually install and remove solar collectors in this area so we can test for some of our vendors, and some of our students can test different panels to see the optimization and the operation requirements of some of these solar panels. This facility is one of the facilities that we've worked extensively with Siemens because it does have it has a multiplicity of different energy assets: solar, photovoltaic, thermal. So we've worked with Siemens extensively to identify and start to audit these energy assets within this facility, similarly to the way we're doing the entire campus. Our goal in this facility is to ultimately come up with that nanogrid system of energy management for the greenhouse and classroom, provide a simulation and training module of that nanogrid system so we can use that to train students on microgrid technologies. And then we plan to extrapolate that and look at our entire campus and create a microgrid system using those same proof of principle concepts with the nanogrid, and provide those same training tools for our students throughout the campus on a microgrid system. And that's our goal within the next year to year and a half. It's a extensive goal. We've never had experience in microgrid technologies here at the community college. We do have a broad experience in renewable energy assets, and we've been building our renewable energy assets. As I mentioned, our goal is to reduce our carbon footprint. But now with the onset of microgrid technologies and partnering with Siemens to gain a better appreciation of integrating that microgrid technologies within our campus and all of our energy assets, we are really looking forward to being able to interconnect our loads, provide management of our distributed energy resources, and literally control some of our own destiny in terms of our energy assets and energy efficiency cost savings. So with that, I think we're open to questions. Unless, Clark, you have anything you wanted to add?
I'd like to just add one thing real quick, Chris, before you go to questions, is I just really want to emphasize what Santa Fe is doing here. You know, I talked a lot of mine about the research side, soliciting new ideas from the students that are looking at these advanced controls. But what are they doing here? They're preparing these students for high-level jobs. I mean, this is something that's extremely important. High-level jobs that'll be part of the community. They can work for the utility there in the state of New Mexico. I know maybe they don't like to hear this as much, but also high-level jobs outside the state, because there's a lack of experience with regards to software controls, and especially where it relates to any type of grid integration. But that's where we're going. We're going towards grid integration. It's not moving away from the grid. It's taking the grid that we currently have and the distributed generation assets that are being added out there, and how do they work together? And a number of utilities are getting this. And it's going to continue to happen more and more. And what are they going to need? They're going to need new bodies and new resources that have an idea on how some of these things work. And here you go. So I just want to make sure that that's emphasized out there for anybody that's listening, because I think that's one of the biggest things that is so important there.
Yeah, thank you, Clark. I mean, you're absolutely correct on that. It's, for us here at the community college, it's all about our students. Obviously, anytime we can provide that workforce training and education that provides those tools and training assets for our students to go out and get a job today, to meet that workforce demand today, which is our goal as a community college. We want to pursue that. And with the onset of solar technology and now microgrid technology, this is a great opportunity for us to provide a whole new transition to our campus to understand and implement microgrid technology, but also to provide that training mechanism so we can start educating our students and helping our students educate the workforce and get jobs tomorrow and today that can satisfy them and their families from here on to the future.
Well, Henry and Clark, you bring up a great point, and the presentation that you've shared with us so far has been really interesting as the number of questions keep coming in. The fact that student engagement and the ability to look at students getting real life experience within our facilities field and our business partners. I know we're going through a major transformation with a number of folks who are leaving, and this is really the wave of the future that's now in learning this. Clark and Henry, you talked about reducing carbon footprint, and that is huge on campus. And so we have Tim Dobson, New Mexico State, the carbon footprint that we want to try to reduce toward our campus, in a number of cases, really reduce it down to zero. Where are you at Santa Fe in reducing the footprint, and what are your plans, projected plans, to overall get down to a zero carbon footprint?
Well, that's a great question. You know, it's been a challenge, first of all, to understand our energy assets here on the college, because this college is now 35 years old. So it's accumulated energy assets and let some of those energy assets transition some of those energy assets over the last 35 years. And it's really important to understand and analyze and ultimately audit all those assets. Yes, the training is extremely important for our students. Our goal is to make sure that our students are trained in those technologies that can get them a job today. Reducing our carbon footprint has been an optimal goal of not only our students, but our campus and our president. We originally started to reduce that goal by implementing and installing a biofuels boiler. We have a wood chip boiler on campus. It's a 1 million BTU boiler, and we've been using that boiler now for over 10 years. And the energy source of that boiler is wood chips. So when we initiated that technology of installing that boiler some 10 years ago, that was really the ultimate goal for us to start reducing our carbon footprint. We're on campus. We have a 1.5 megawatt photovoltaic array. We have another 12 kilovolt array system. And on our higher education campus, we have a 450 kilovolt photovoltaic array system, both rooftop and parking lot. So our carbon footprint for the main campus now is reduced by about, well, I'm going to say close to 60%, excuse me, close to 40%. We are providing about 45% of our energy needs on the main campus with all of our combined energy assets, renewable energy assets. And at our higher education center, we're providing about 85% of our energy requirements with our renewable energy assets. So we're getting our carbon footprint on main campus down to about 50%.
You're definitely well on your way going towards zero. Excellent job there, Henry. Hey, we have a question from Ed. He loves the student engagement. Could you talk a little bit more about that, integrating the student engagement with the academic side of the house, working with the department deans and professors?
Yeah, thank you. Yes, that's a very, very critical aspect of any project we do here at Santa Fe Community College, but in particularly renovations, new construction, and obviously anything associated with our energy assets. It's our goal here at the community college. We've always wanted to include our students. So anytime that we come up with a conceptual idea, or the community helps us, or students come up with a conceptual idea, we actually incubate that idea within our classrooms and within our student communications. And then we graduate that idea through our student groups. It goes on into some of our faculty, and it actually precipitates itself up into some of our professors and ultimately to some of our administration, and eventually up to our executive team, which is where we actually address this from an executive team level. So our goal is, with any project on campus, is to make sure we involve the students, because it's that student input at the end of the day that not only makes the project a success, but it leads us to providing a greater educational experience for our students.
That's excellent. And maybe we can follow that question up, because that's ultimately why we're all here, is to see our students graduate. Adam Flint has talked about how they have an energy core of internships. They've hosted over 87 students within energy projects. Clark, could you go ahead and comment? Are you all doing internships at Siemens? And this just seems like a great opportunity.
Yeah, absolutely. Even with regards to software controls. So that it matches up. We do a lot of that, and we have done a lot of that over the years. So we believe strongly in the importance of it. I'll say selfishly, it allows us to take a look. Why don't we call it like a 2.5-month interview, right? For the student or students that get to work within the organization. And worst case scenario for them is they get real life introduction to what's going on within that part of the organization, within Siemens that they're working with. I can speak specifically to one that worked with us a couple of summers ago, worked directly with my team. And initially, he was going to have some specific tasks that we felt he could complete, a lot of research that we felt we needed an extra resource to accomplish, and he did all that. But turned out, as we got to know him better, we realized the potential that he has, and threw him into project proposals, threw him into looking at how we do things, because again, what does it do? It gives you a totally different perspective from somebody that isn't working with you on an everyday sort of way, and that's helpful. And so that's, again, one of the benefits for us, having the intern as well. So we recognize it benefits the student, but it really benefits the company as well.
Well, this is perfect. You know, we must have hit a topic that is really important to all our members. We have one of our gentlemen saying, you know, I'm going to be sending this to my grandkids when they start looking at key topics for their career. And as everything keeps changing so quickly, this is really right on top of the curve. If we can go ahead and move to another key question, and this is for Henry. Henry, you mentioned at the beginning of the presentation, you have to have leadership aboard. Without senior leadership aboard, it's just not going to happen. Can you review, Emily Clark, who's on the line here, can you review what was that whole process? How did you get your president and your senior administration aboard?
Well, thank you. That's a great question. You know, it's a process of really identifying to your peers and your colleagues within the college of what your energy costs are associated with the cost of tuitions and fees for your community, for your college. So we physically analyzed the cost of energy per student. We came up with that ratio. And we look at that cost of energy associated essentially with our utilities. We look at our energy costs, our water costs, our waste costs, and we calculate what that is per student. And so we came up with a ratio, and we use that ratio to not only show what the students are paying for out of their tuition fees for the cost of energy, but also how that cost could be managed better, and to the extent that we not only implement conservation techniques, but we also look at how we could perhaps combine those energy resources into a single controllable entity like a microgrid system, and start managing those assets to reduce our peak loads and reduce our energy consumption by managing on and off times of our plant, by managing on and off times of our lighting, and by really understanding and appreciating how our plant operates with respect to energy. And so when we enlightened and enhanced all of our executive team and the presidents with these aspects of how we could do a better job managing our energy. And oh, by the way, our energy costs are, in our case at the community college for us, energy costs are about a fourth of my operating budget for the plant, which is quite substantial. Everybody will listen if you can identify a way to not only manage those costs, but perhaps come up with a savings. And so once you identify those assets and come up with some, some options and suggestions for reducing those costs, people start to listen, and that's what created a listening from our president, and that's what brought them to the table.
Well, and that brings a great point, and the question is the overall cost of utilities on our campuses, on our community colleges, and how our facilities professionals can continue driving that down. We have another question that has come up regarding that. Adam Flint and Christopher Madden, I mean, the questions just keep coming in. It's about the analytics, Henry, and maybe Henry and Clark can jump in there and just a little bit more on the analytics of what you're looking at when you're trying to measure. If you can't measure it, you can't improve it. But what you're trying to look at so you can then paint that picture for administration.
Go ahead, Clark. You want to take a first stab at that? Then I can I'll give them a practical example of how we look at it in a physical plant.
Sure, that's perfect. Yeah, because I want to go from a broad perspective. One thing that was really amazing to me when I came into this business about almost 2 years ago now is where opportunities are applicable for to utilize advanced controls. I figured, okay, CHP, you put that in, you better have 10-cent power. Solar was dropping down at the time. I think we were at 6 or 7 a couple of years ago, and we're lower than that now. So I was kind of thinking that the microgrid controller would work in the same areas from a cost standpoint that the distributed generation assets started to make economic sense. And so, big surprise, we see opportunities in areas with 5-cent power. How can that be? Well, it can be because you have reliability. There's some reliability. They want to have and the need to have that backup power in case something happens. It's not that the utility is not doing a good job. It's just they need that assuredness. If something does happen, okay, what's our emergency plan? It's not applicable this analogy is not applicable, but did Florida really have an emergency plan when that storm hit? I don't think they really did as a state. There were little pockets possibly. And so, yeah, we're not going to have the same thing at any singular higher ed campus, but it's important to have that emergency plan, and that's worth something. Additionally, the ability to optimize distributed generation assets that are there, backup gen sets, combined with solar that have been put in there, well, now you can optimize those using an advanced control system. That's going to save you money, even if you're at 5-cent power. So there are elements that when I first started this job, I didn't think were there, but now I see how they are, and we're seeing the applications, and that's what's really been fun and interesting, and also very hard to track when you're trying to plan. Okay, well, where should we focus? But anyway, that's my problem. Anyway, great question. Yes,
and let me just add on to your discussion, Clark. It's extremely important that as a physical plant manager, that you understand your energy and utility costs. I mean, I spend a significant amount of my time managing my energy and utility costs. I look at those costs, I analyze those costs, I look at trending data on those costs, because I want to understand what am I spending on energy and what can I do to reduce that cost, because those are substantial costs of my operation. So take that leap, get those utility bills, review those on a regular basis, compare them to previous years, previous months, call your utility company up, get a better understanding and appreciation, understand those energy assets and how to manage them. And you'll be well on your way to optimizing those. And as Clark just mentioned, once those energy assets are understood, audited, and analyzed, and you bring them onto a management system, now it's a matter of you managing your loads and controlling your energy costs.
Excellent. Thank you, guys. Following up on the reliability, I believe you mentioned you have some turbines on campus, combustible generators. And how much of those load did you say is producing electricity on your campus? And then also, are they standalone that you can use the microgrid? As you mentioned, reliability, that if the local provider fails, can you still power up the campus?
A great question. You know, we're currently on campus. We have a number of generators, but they're all used on a backup basis. And most people are familiar with power generation is a backup resource. If the event you lose power, you have backup generators to bring your at least critical systems online until your power is restored. This whole concept of microgrid now takes the concept of generation from backup to primary. Total different concept. I'm now using my generator, well, as soon as we bring it online with our Nanogrid, we will be using our generators now to manage as a primary source of energy as opposed to a backup source. And it's a whole different generator, and you have to spec and operate that generator within different environmental standards. But once you understand that as a primary source of energy, and you identify that power generation and manage it as a primary source, now you can start reducing your energy costs by attacking those peak demands using alternative energy resources and shading those demands so they don't get to a peak. So to answer your question, we're going to be bringing these energy assets, including power generation, battery storage, onto this greenhouse within the next 3 months, and we'll flip that Nanogrid switch on, and we'll actually start managing and controlling those assets.
Thank you, Henry. And Avery Ashby, just kind of a follow-up question on that. In the past, your local provider, what was the number of times or percentage that you would have some blackouts, you would lose power, and since you've gone on to the microgrid, Nanogrid, has that been totally successful in eliminating that?
Well, thank you for that question, because not only is it a matter of you know, documenting and trying to understand those power outages, but it also causes hazards, and it causes maintenance issues on campus with systems that don't want to start up. And now you got to go troubleshoot why that system didn't start up. And so any power outage is not a good power outage. It always causes some reprehensible damages to your equipment. So it's important to mitigate and avoid power outages. We, as a community college here within our county, experience a power outage on average at least once a month. And that's unfortunate. Again, when you restart the campus after a power outage, it never fails, but there's always something that creates a problem, and then you have to go troubleshoot. So power outages are really more of the cost of doing business that you should try to avoid.
Excellent. Thank you, Henry. Clark, we got a great question. We have our friends from Canada. I mean, these webinars are stretching throughout the United States, up into Canada, down to Mexico. Emmett Boyle, who's the who's the vice chair for our junior and senior reps, is just doing a great job on our APA board up at the University of Regina. We appreciate everything Emmett is doing for APA. He's talking about solar, about smart buildings and smart building controls. And I know you talked about that, Clark. Can you give more details on that? Because that's really the wave of where our buildings are going, driving down our operating costs.
Sure. So there's a couple of things. I'll have some fun to start out by saying, go ahead and Google Algonquin College up there, since you're north of the border, and that's one that you're going to see number of articles. You're going to see, I guess, selfishly promote myself on there a couple of times with, I'll say, Henry's counterpart from Algonquin College. So you'll hear us speaking about their distributed generation assets and their microgrid as well, if you just want to have some fun on your free time. But your direct question with regards to the smart buildings, again, this gets back to, okay, what is it that you're trying to accomplish, capabilities and functionalities, and let's get specific. Let's look at a program, just like they're doing at Santa Fe Community College. You know, I talked about the microgrid part, that's the generation asset part, but my sister division, Building Technologies, is working with them, and they are integrating other building management systems and improvements within the various buildings. So this is working in conjunction with each other, both inside the building and outside the building. And so that's really why I say this, you're at the planning stage. So if you remember that one slide of consulting, you're at the planning stage. Let's figure out what it is you actually want to accomplish. If that can be done through a building management system, then great, because you probably already have one, and maybe that's something you can implement or augment with another one or an addition there. If it needs an additional advanced control system, then we'll figure that out as well. And it's impossible without knowing the specifics and where you want to get to be any more precise than that. But I hope you get where I'm coming from. Is there's more than one way to skin a cat, as we say in the South. And so we'll look at what you want, put together options, and that's the step one, and then we'll figure out what the equipment that you need in order to accomplish that.
Excellent. Thank you very much, Clark. You know, we have about 6 minutes left. We're going to do a little summary toward the end, and so we still have questions just coming in. And so what we want to talk about, and also, by the way, Clark, you have somebody who would love to do an internship with you. We'll get you all the information. You can follow up from there. So this is very helpful too. It's a grad student working on his PhD. But solar, Clark, you talked about solar. You know, for a period of time, the cost of solar was rather high, and you threw around some numbers there that are sounding very attractive. Can you and Henry talk a little further about solar and how that's intertwined into the microgrid?
Sure. I'll go first, Henry, and then you can talk about it specific to your campus. How about that?
Okay, sure.
Okay. So across, what's happened across the country, I think you've really seen since 2008, a significant increase. At one point in time, I think the first 5 years increased 34% year over year. I think now it's dipped maybe below 20% year over year as far as increase on the number of solar projects that are operational across the country. And yes, that's all combined, residential, commercial, as well as large solar farms. That's really all of it combined. But the point is, there's growth there. And that growth has all happened literally in the last 10 to 12 years. And what's the reason for that? The reason for that is the cost has dramatically decreased. Now, we're going to have a blip in the cost because of the recent legislation with regards to the tariff. And I think, you know, those of us in the industry, you know, recognize that. I'm going to call it a blip because it's going to mean that the panels are more expensive than they had been. Okay, but other elements of it are still being reduced. How much it costs to install it, that part of it is still going down. And we're at a point where we really do have, I think the solar people would say, grid parity for the most part. When I switched jobs, I actually was in that business until I switched to this job 2 years ago. We didn't have grid parity except for maybe 10, 15 states, but now we're there, and that's great to see. Now, don't want my utility friends out there to start freaking out because they are right. You only have solar for a certain part of the day, and so that creates disruption and that we have to balance. And that is very, very accurate. So as we look at the different solar projects out there, we have to evaluate how does that affect that local grid, that local feeder, and that local substation. And that gets back into that term of grid integration. So I'm going off a little bit on a tangent on you there, Chris, but I think it's important because the utilities that are looking at grid integration are evaluating the distributed generation assets within their service territory and figuring out how to maximize that investment and those assets that are within their service territory. And there are a number of them that have come out and said that. And I will say that I think that's going to spread like something that's very good as other utilities see what some are doing. And as that continues to play out, it's going to make a difference in the industry.
Excellent. Well, you guys, we got about 3 minutes left. Henry, do you want to comment on that further before we go to a wrap up here?
You know, I think I think Clark covered that pretty well. I haven't researched the cost of solar much on a commercial basis for the college, since we installed our system over 2 years ago now. But I think it's about $3 a kilowatt hour. Excuse me, $3 per watt in terms of commercial costs of solar now. I think it's important to look at those costs now because they've come down significantly. And really, with the onset now of new technologies coming with battery storage and energy storage, I think it's important to couple that technology with solar and perhaps even reduce the total amount of solar generation you need because of the power, because of the availability of power storage, energy storage, and those costs have come down to augment the cost of your operational expenses and utilities. And I think over the long run, we've experienced somewhat of about a 35 to 40% cost savings on our energy since we installed our photovoltaic.
Well, guys, we have about a minute before we wrap it up. I do want to thank both of you for all your knowledge. Santa Fe and Siemens. Siemens has been just an outstanding business partner with APA. Henry, if you can just real quickly, the main purpose of your microgrid, just really the overall summary of basically everything we've covered today, just real briefly.
Well, thank you. I appreciate this time to allowing us to provide expertise and knowledge associated with our experience implementing microgrid technologies here at Santa Fe Community College. Our goal is to enhance our educational opportunities for students with regards to current workforce demands, and in this case, solar energy and microgrid technology is an up-and-coming technology. So we want to provide those.
Chris, you were kind of going in and out there. I don't know if we're having trouble.
Oh,
Henry, can you hear?
Not.
Yeah, it sounds like we're bouncing a little bit.
I don't hear Henry. I'm just gonna jump in. I know we're at the last minute, so I think.
Go ahead, Clark.
Yeah, no, the main purpose of the microgrid, it's twofold, right? It's the education and research, as well as on the campus side for reliability and cost control. So they're looking at it from both those perspectives, and then the great part for the students is they're going to be able to see what happens on their campus, and then they're going to be able to run simulations and, like I said, utilize ideas of their own. Maybe they're going to come up with the next great idea to say, hey, Henry, you need to put in a fuel cell or something else that's fun that's going to reduce your cost because of X. They may come up with an idea.
Well, guys, we're just right now about out of time. I do want to thank both of you for taking time out of your busy schedule. We have so many questions that's still coming in. We don't have enough time to answer them all. But what we will do for all our APA members who have sent questions in, we will answer those. They will be on the APA webpage. We are recording this. We'll have the PowerPoint there over the next couple days. We appreciate Billy in the APA main office for all her support with the webinars. And also, this webinar series, the whole idea was to give back to our members. And we're doing another webinar tomorrow. As APA president, we've started these on the 4th Thursday. We have another one with the great partnership we have with ASHRAE. And Daryl Boyce, who will be the president of ASHRAE, currently the treasurer, will be talking about building EQ. Right in line kind of what we're talking about today about microgrids, nanogrids, and understanding our energies coming out of our building and how can we make our buildings more efficient. That'll be tomorrow at 12 o'clock to 1 Arizona time. And Henry, Clark, again, we appreciate your time. Henry, since we have you on the line, is Brother Ron at your university at Santa Fe?
Brother Ron?
Yes. Does that ring a bell?
Not off the top, no.
Okay. I thought he was. If he is, make sure you say hello. He's a great guy. But Henry and Clark and Billy, we appreciate everybody's effort. Any final last words, Clark? And Henry, you there?
No, just other than thank you all, and really appreciate this opportunity. Really looking forward to working with APA on future webinars.
Well, thank you very much, both. We appreciate it. And thank you, APA members, for joining us. Have a great day. We'll talk to you hopefully tomorrow. Take care. Bye-bye.
Thank you. Bye-bye.